Hi math students, today we're going to look at factorising a cubic function using polynomial long division. So how do we know what bracketed factors can be used to factorise any given cubic in the first place? Well, it's a pretty fun process. So what we do is, if we know the generic form of a cubic is this ax cubed plus bx squared plus cx plus d, all we do is we look at the coefficient of a and the constant at the end there, d, and we take those values and we multiply them together, and then have a think about what factors of that multiple a times d could we possibly have. So for example, I've got two little cubics here to factorize. So I've got x cubed plus x squared minus 14x minus 24 and x cubed minus 2x squared minus 5x plus 6. So if I look at what is in the A and the D position in that cubic for both of those, 1 multiplied by negative 24 gives me negative 24. If I think about factors of negative 24, this could include plus or minus 1 by plus or minus 24, 2 by 12, 3 by 8, any combination of those. If I look at the possible factors of 1 by 6, so factors of positive 6, I would have to consider things like 1 times 6, negative 1 times negative 6, 2 times 3, negative 2 times negative 3. So any combination that works to give the value of positive 6 there. After I've identified these factors, then it's a bit of a trial and error. And what we do is we focus on the lower end value factors. So I probably would always start with positive 1, negative 1, positive 2, negative 2, working my way up there. And what we do is we assume that the factors are in the form ax plus or minus b. And for the purposes of these types of cubics, we're just going to assume that there's no value greater than 1 for this a position coefficient. So we're going to assume that a is going to be 1, and then the b part is going to be our plus or minus factor. So say I wanted to test whether x minus 1 was a factor. If we look at this in this format, you should be able to see that that's like saying 1x minus 1. So you can see here that the a is 1 and the b value there is negative 1. Secondly, from there, we use something called the factor theorem that states that in order for the factor we've identified to be a factor, then if I was to sub in that into the function, I'd end up with an overall value of 0. And to identify exactly what to sub into the function to test it, I kind of need to do like a little bit of a reverse process of the null factor law. So say I wanted to test my factor of x minus 1 that I identified just before. I would make that factor equal 0. So you might recognize that as part of that null factor law process from solving quadratics. And what you're trying to do is kind of reverse that and go, okay, if x minus 1 equals 0, that means that if I add 1 to both sides, what I'm actually subbing into my function is x equals 1. So if I was testing that in my function, my defined function of f of x, I would simply substitute in x equals 1 into my function. Okay, let's come back to the two examples we're looking at. So I have a sneaking suspicion that x plus 2 equals 0 might be a factor. So what I would do is rearranging that in that kind of reverse null factor law thinking. What I'm actually subbing in is x equals negative 2 into my function defined by x cubed plus x squared minus 14x minus 24. So if I sub that in, you can see I get 0. So this confirms that for this first function, x plus 2 will be a factor of the cubic. If I look at the other example, the second example, I think x minus 3 is going to be equal to 0. So if I rearrange that by adding 3 to both sides, what I would be testing is x equals 3, which I substitute into the function. When I do that, you can see that that pops out 0. So that confirms that x minus 1 will be a factor of that particular cubic. The next thing we do is the actual polynomial division process. So I've identified for this first example that x plus 2 is going to be a factor of this cubic. So we kind of set it up like the long division, and we put in the factor that we're trying to divide out under our long division sign, as well as the cubic itself. And this is a bit of a to and froing process. So moving forward, what you're doing is you're grabbing the x at the beginning here and you're saying, okay, how many times can that x go into x cubed? So you're kind of going x cubed divided by x, and that gives me x squared. Then, so it's kind of like a moving forward process, and then you come and cycle back. So moving forward, you only worry about the x, but moving backwards, it's a little bit different, where you're cycling back and going, okay, x squared times by x gives me x cubed. And this is where it's a little bit different when you cycle back. You also check x squared times 2, which will give me plus 2x squared. Okay, and you kind of finished off that moving forward and cycling back process. So you hold it up, rule it off, and then you do that subtraction process. So x cubed minus x cubed will give us 0. And then if we look at the fact that x squared minus 2x squared, I'm going to end up with a singular x minus x squared left. So I've kind of finished off that first rotation. And I repeat. So now I grab this x again, and I go, okay, x into negative x squared will give me negative x. Then I cycle back again now. So I go, this negative x times x will give me negative x squared. And I can't forget on the cycle back to also apply it to the 2. So I'll go negative x times 2 gives me negative 2x. I rule it off, and I can't forget to bring down this guy up here to the party, and I do my subtraction. So x squared minus x squared, so remember that will turn into a plus. So I've got negative x squared plus x squared, which will give me 0. Then I've got minus 14x minus 2x. So in fact it's saying minus 14x plus 2x will give me minus 12x. Okay, and I've finished that rotation now. Okay, for the final one, we will have our x now trying to go into negative 12x. So that will give me negative 12. Okay, time for the cycle back. So I'll grab that negative 12, apply it to the x. So negative 12 times x will give me negative 12x. Can't forget to also apply it to the 2. So negative 12 times 2 gives me negative 24. Rule it off. Can't forget to bring that guy down to the party. Negative 24. Okay, apply the subtraction. So negative 12 minus 12. So negative 12 plus 12 gives me 0. Negative 24, take negative 24, so negative 24 plus 24 gives me 0. And I've completed the polynomial division to give me my quadratic that I can now move to further factorize if possible. Okay, if you'd like to work with me, press pause and give the second question a go, and we'll go through it really quickly in a second. There you go, let's check in. So x into x cubed gives me x squared. X squared times x gives me x cubed. Can't forget x squared times negative 3. Negative 3x squared. Rule it off, subtract them. Get 0 and x squared, so negative 2x squared plus 3x squared gives me x squared left over. X into x squared gives me x. X times x gives me x squared. X times negative 3. Rule it off. Bring this guy down. That gives me 0. Negative 5x plus 3x gives me negative 2x. Start the cycle again. So x into negative 2x gives me negative 2. Negative 2 times x gives me negative 2x. Negative 2 times negative 3 gives me positive 6. Rule it off. Bring this guy down. Negative 2x take or plus 2x gives me 0. 6 take 6 gives me 0. So I'm done and I have my quadratic. Alright, last stage is just factorizing the leftover quadratic if possible. So I know that I've got my x plus 2 removed out. If I look at this quadratic, what two factors of negative 12 here add to give negative 1? Hopefully you're thinking negative 4 and positive 3, which then can be split even further. Highest common factor of x here. So if I remove that out, I've got my x plus 2, x minus 4, x plus 3, fully factorized. Let's pause and see if you can do it for the second one. How did you go? hopefully that's what you got.